Hey guys, welcome to this video where I'll be going over paper 1 for the higher tier. Paper 1 is a non-calculator paper. The topics in this paper are compiled using the advanced information that have been released by the Edexcel Exam Board. So go grab those pens and your notepads and make some good notes. Let's go. So we'll start at the back of the paper. This question here is a question on vectors. So we are told that O to A is equal to 2A. Let's write that in. That's O to A right there, and that's equal to 2A. And we're also told that O to B is equal to 2B. So there, that's 2B. Then we're given the information that N is on the point O to B. So O to B is right here and N is right there. Okay, and it's in the ratio 2 to 1. So what we can do here is say this is 2 and this is 1 part. And we are told that M is the midpoint of A to B. Is A to B right there and M is in the middle, which means that this is exactly half of the full AB. And we are told that P is on the point O to M such that APN is a straight line. So APN is a straight line. So this is all the information that we've been given. And we've been told to find the ratio of O to P, P to M right there. So where do we begin with a question like this? Well, the first thing that I'd like to do is write down the paths for these ratios. So we've got O to P here and we've got P to M. So let's go ahead and find O to P. So number one, we are going to find O to P. Now, where is O to P? Well, here's O and here's P. How do we get there? There are various routes that can get us there, but we know the most straightforward one is O to P right there. And O to P is a part of the full O to M. So what we can do now is say that O to P is a part of O to M, the vector O to M. So once again, here's O to M and O to P from there to there is a part of that. We don't know how many parts. Now because we don't know how many parts, what we can say is something like X amount of O to M. So an X amount of O to M, like a fraction. So now that we know that X is a part of O to M, let's go ahead and find O to M. So what is O to M? Let's have a look on our diagram. Here's O, here's M. How do we get there? There are two different ways that we can get there. We can either go this way, or we can go there, O to A, and right there. I'm going to choose to go from O to A and A to M. I'm going to go that way. You could choose the other way if you want to. So, what is O to A? Well, we know that O to A right there is 2A. So, O to A can be replaced by 2A. And what is A to M? Well, we know that M is a midpoint. We are told this right here. So, therefore, A to M could be a half of the full A to B, which is all of that. It's a half of that. So we can now find A to B. What is A to B then? So A to B is simply, we want to go from here to here, so we can go back this way and then that way. So it's going to be minus 2A, it's going to be minus 2A that way and plus 2B that way. That is A to B. So it's going to be minus 2A plus 2B, and we can write it as 2B first, so we have that as positive minus 2A. So that is A to B. So this A to B, what we can now do with this A to B is just substitute it in here. So what do we have? We have 2A plus a half, and now A to B, which is 2B minus 2A. And if we simplify this, what do we get for O to M? We have 2A plus half times 2B is just B, and a half times minus 2A is minus A. So we have 2A minus A, which is just A, and then plus B. So O to M is A plus B. Now, why were we working out O to M? Because we needed it right here. So now we can come back here and we can say that O to P, which is what we were trying to find out in the first place, is equal to X bracket A plus B, which is O to M. So this is what we have right now for the value of O to P. So where do we go from here? Well, we found O to P, a version of O to P that goes from there to there. What we can do is find another route to go from O to P. And then what we can do is equate it to what we have right there. And we can solve it simultaneously. So let's go ahead and do that. So just scroll out a little bit here. So what we're going to do now, second, is we are going to find another route for O to P. So previously for O to P, we just said, right, O to P is a part of the full O to M. But this time what we're going to do to go from O to P is use another route. So we can go, for example, O to A and then A to P. Okay, so let's go ahead and do that. So we can go O to A and then A to P. Now A to P is also a part of A to N. So here's A to N, and we know that A to P is a part of that. We don't know how many parts. So once again, just like before, what we can say is O to A, which we know is 2A, plus a part of A to N. So just like before, what we can say is 2A plus Y as a part of A to N. And now, just like before, we just need to find what A to N is, just like we did O to M earlier. So to find A to N, what we do is we trace a route. So here's A, here's N. How do we get there? We can go from A to O backwards, which is minus 2A, plus A to N here, which is 2 parts out of the 3 parts in total of O to B. So what we have is A to O plus O to N, which is our root. And we know that A to O is minus 2A, because you're going backwards against O to A. Plus 2/3, so we know that this is 2, worth 2, and this is worth 1. So in total, O to B is 3 parts. So we only want 2 of those parts because our ratio is in the ratio 2 to 1. So therefore, 2/3 of O to B. And we know that O to B is 2B, just like we told in the question. So we have minus 2A plus 2/3 of 2B. And if we simplify that, let's just scroll up a little bit here, we get minus 2A plus 4 over 3B. And once again, we can put the positive first, so 4 over 3B minus 2A. And that is the value of A to N. And now what we'll do is just substitute it in there. So we have, therefore, O to P is equal to 2A plus a Y part of 4 over 3B minus 2A. And then we can just expand this out. And what do we get when we expand this out? We get O to P is equal to 2A plus 4 over 3YB minus 2YA. Right, so what do we have? We have 2 different variations for O to P. We have this one that we just found and what we found earlier on. So what we now can do is just equate both O to P's and solve them simultaneously. So let's go ahead and do that. So equate both O, P. Okay, so the first one we had X bracket A plus B, and that would be equal to 2A plus 4 over 3YB minus 2YA. And now what I'll do is expand the first side here, so I get XA plus XB is equal to 2A plus 4 over 3YB minus 2YA. Let's now simplify this side over here because we've got A here and we've got A there. Let's have them together. So what we can do is say 2A minus 2YA plus 4 over 3YB. And what we can do is take the A's out, i.e. factorize them. So if we have a bracket, let's say 2 minus 2Y, and then that we can have as A, and then we'll have 4 over 3YB. So On the other side, we are still left with xa and xb. So what we can now say is because they are both equal to each other, this side is equal to that side, that means that this one's a is equal to that one's a. And this one's b is equal to that one's b. So in other words, x is equal to 2 minus 2y, and x is equal to 4 over 3y, and that's your b's. So all we've done is collected our a's, which are here, and our b's, which are there. And then we just solve them. So let's take this equation and make y our subject. So we're going to multiply by 3, so we have 3x, and then we're going to divide by 4. So therefore, y is now our subject. And we are going to substitute that y right there. So on this side, what do we have? We have x is equal to 2 minus 2 times 3x over 4. And then we're going to expand this out. So we get 2 minus 6 over 4x, and 6 over 4 is 2 minus 3 over 2x, and that's equal to x. Let's collect all the x's on one side. Remember, this is a non-calculator paper, so all your techniques and methods have got to be without the use of a calculator. So how do we do this? I prefer to multiply the denominator on the fraction, so I get 2x is equal to 4 minus 3x, and then I can take the minus 3x to the other side, giving me 5x is equal to 4, and therefore x is equal to 4 over 5. So that's my value of x. So now that we know the value of x is 4 over 5, let's go back and look at our diagram and our equations. So the first thing I want to show you here is that x right there is from a part of O to P. And the part of x is right there, which is 4 over 5. So let's write that in here right now. So if this is 4 over 5 from here to here, then that means this is going to be 1 out of 5. So in other words, we have OPM in the ratio of 4 and 1. So therefore, if we are looking for the ratio O to P and P to M, it's going to be 4 to 1. Now obviously there's so many steps in this, and you've really got to make sure that you understand what you're doing, and that's why making sure that you have your diagram well organized and well labeled is the first step in making sure that you get these right. All right, question 24. We have a circle with the equation x squared plus y squared equals 7, and we are told that P is a point on the circle. Work out the equation of the tangent to the circle at P. Let's draw a little diagram of what this looks like. So if I draw a graph right there, like that, now the center of the circle is going to be 0, 0, because we have the equation as x squared plus y squared. We don't have anything being taken away from x or y or added. So it's 0, 0. So it's going to be right there. So we will draw a circle. So here is my circle right there. We are told that the point P is minus 2 root 3. So let's just put it somewhere here. So minus 2 root 3 right there. And we are working out the equation of the tangent. So the tangent will be a line that comes and touches this circle at that point right there, something like that. So we know that the tangent and the radius meet at 90 degrees, and the center of the circle is 0, 0. So we'll be working out the equation of this line. So y is equal to mx plus c is the form that we want. So we want to find, first of all, the gradient m. Now the gradient m is going to be the negative reciprocal of the gradient of this line right there, which is the radius. So let's go ahead and find that first. So m, let's call it m1, is going to be root 3 minus 0 divided by minus 2 minus 0. And that gives us root 3 over minus 2. So therefore, the gradient of our tangent, let's call it m2, is going to be minus 1 over root 3 over minus 2. And that gives us a positive 2 over root 3, which we can also rationalize as 2 root 3 over 3. Now, we have y is equal to, let's use the rationalized form, so 2 root 3 over 3x plus c. So now we just need to find the value of c. How? By plugging in a point, a coordinate that the tangent goes through, which is of course p. So we'll sub p minus 2 root 3 into our equation. So root 3 is equal to 2 root 3 over 3 times by minus 2 plus c. Now we'll just simplify this. So we have minus 4 root 3 over 3 plus c. Next we'll multiply by 3 to get rid of the denominator. So we get 3 root 3 is equal to minus 4 root 3 plus 3c. Take the minus 4 root 3 onto the other side. So we have a positive. So we're going to add 4 root 3. Both of them have root 3, so we can collect them together. So we have 7 root 3 is equal to 3c. And therefore c would be equal to 7 root 3 divided by 3. So the equation we have of our tangent line is y is equal to 2 root 3 over 3x plus 7 root 3 over 3. And that's your final answer. Okay, question 23. We are told that BAC is a sector of a circle of the center A, and A to C is 10 centimeters. Find the area of the shaded segment. Give your answer in terms of pi. So, if we have the area of the sector and we take away the area of this triangle right there, then we are left with the shaded region, which is right here. So let's go ahead and do that. So let's label our triangle here. So 10 centimeters, 10 centimeters. Right, let's find the area of our sector. How do we do this? We know that 60 over 360 times by pi times r radius, which is 10 squared. And then how do we find this area of our triangle? We can use our sine area rule, which is half times by AB, which is 10 times 10 in this case, times by sine 60. And that would equal what we need, which is our shaded area. So let's go ahead and simplify all this. So we can divide here. So 6 over 36 is 1 over 6 times by pi times 10 squared, which is 100. So 100 pi, which simplifies to 100 over 6 pi. Next, let's go ahead and do that. So that's a minus there and a minus there. So we have 10 times 10, which is 100. 100 times a half, which is 50, and sine 60. So what's the value of sine 60? We can use our triangle. So sine is opposite divided by the hypotenuse, so root 3 over 2. So root 3 over 2 is the value of sine 60. So we can come back here now and say 50 times root 3 over 2. So 50 and 2, that gives us 25 root 3, and 100 over 6, that can be simplified as well, giving us 50 over 3 pi. So 50 over 3 pi minus 25 root 3 is the area of our shaded region. Question 22, the table shows pairs of values for x and y. Part 1, tick the correct statement below. Part 2, write a formula for y in terms of x. So where do we start this question? We have 3 different statements here. We have y is proportional to x, y is proportional to the square of x, and y is proportional to the cube of x. Now, what we can do is start by using one of these pairs, so x and y here, testing it on the second pair. So what do I mean by this? Let's start with the first statement. So let's take y is proportional to x. Now I'm going to replace a proportional sign with equals k, and so we have y is equal to kx. So we're going to test this now. So we're going to test this using x as 2 and y as 32. And I've just got that from this table. So I'm going to find the value of k using this. So therefore 32 is equal to k times by 2. So therefore k would be 32 divided by 2, which is 16. So therefore this equation becomes y is equal to 16x, All I've done is once I found the value of k, I've just replaced it right there, like I have here. All right. Now I'm going to use that to test the second coordinate, which is when x is 3 and y is 72. So therefore, I'm going to test this using 3 and 72. Let's see if it works or not. So y is 72. Is going to be equal to 16, which is my value of k, which I found earlier, times by my x, which in this case is 3. Now, what is 16 times 3? It is 48. So therefore, it is not 72, and therefore, this is not one of my equations. I'm going to now test this using the second one, which is right there. So, number 2, y is proportional, again, equals kx squared. I'm going to now test it using this. So therefore, y is going to be 32, k times 2 squared. 32 is equal to k times 4, and therefore k is going to be 32 divided by 4, which is 8. So therefore, I have y is equal to 8 times x squared. Now, let's test it using this. So y is 72 is equal to 8 times by 3 squared. What does that give me? 8 times 3 squared is 9, and 8 times 9 is 72, and therefore we have a match. This means the second one is our answer. We don't need to practice this on the third one because we already have our correct statement. Now for part B, which says write a formula for y in terms of x, we've already done it, which is simply this right there. So we can just write that for part B, and we can say y is equal to 8x squared. So question 21, here is a speed time graph. Work out an estimate for the acceleration when t is equal to 2. Right, let's go and find where 2 is. It's right here, it's about there. So what we now want to do is draw a tangent to this point, and we are going to work out the gradient of that tangent, and that gradient of that tangent is going to be the acceleration that we need. So let's go ahead and do that. So here's the line that I've just drawn, and we can find the gradient of this line in one of two ways. We can either draw a right angled triangle underneath this, and then just find the distance here and the distance there, and then do y divided by x. Or what we can do is just find two separate coordinates. So for example, right there, which is what's that, 0, and that's going to be 5, 6, 0, 6, and find another one over here, something nice in the corner right there, which is going to be 3, and what's that, 31, 2, I think these are odd ones, so 39. So we have 0, 6 and 3, 39, and therefore the gradient would be 39 minus 6 over 3 minus 0, which works out 39 minus 6 is 33 over 3, and that gives us 11. And your answer could be approximate to this, so if you've done this and you've gone a little bit different with your values for both these coordinates, that's completely all right. So if you get something like 10 point something, whatever, that's perfectly fine as well, because it does say an estimate, work out an estimate for the acceleration. Question 20, given that, and you've been given this ratio, find the possible values of x. Right, so we know that this side is equal to that side. So therefore, this ratio here is going to be equal to that ratio there. If we take this and divide by 2x plus 1, we can make this equal to this divided by x plus 8. So 3x minus 4 divided by x plus 8. And there we now have two equivalent fractions, which are algebraic fractions, of course. And we just deal with them as we would with any algebraic fractions. So we're going to cross multiply. So we're going to have x plus 2, x plus 8 on this side, and 3x minus 4, and 2x plus 1 on the other side. So if we expand this side now, we get, and the other side we get, collect all the like terms, And now we're just going to take everything over to one side. So we're going to take everything on the left hand side over to the right hand side, because it's just much easier to do that because we have x squared as positive. So this side will be 0, 5 squared minus 15x minus 20. Now if we divide this by 5, we get x squared minus 3x minus 4. And we can just factorize this. So x, 4 and 1, we have plus 1 minus 4. So therefore x is equal to minus 1 and x is equal to 4. And there you have your possible values for x. Question 19. Write 3 minus root 8 all squared in the form a plus b root 2, where a and b are integers. Alright, so if we expand this bracket, we have 9 minus 3 root 8 minus 3 root 8 plus, because the minus and the minus is a plus. Now what you can do is, if you do root 8 times by root 8, you could write root 64, or you could just write 8. So I'll just write 8. Next, we collect all the like terms. So the 9 plus 8, that gives us 17. Minus 3 root 8 minus 3 root 8 gives us minus 6 root 8. Now the question does say that it wants it as a root of 2. So this 8 needs to be broken further. So 8 can be broken up as root 4 times root 2, which is 2 root 2. So if we come back here now and we write 6 times by 2 root 2, so minus 6 times by 2 root 2 gives us minus 12 root 2, and we have 17 from the other side. So 17 minus 12 root 2 is our final answer. So question 18, the diagram shows a cuboid. All the measurements are in centimeters. The total surface area of the cuboid is 172 centimeters squared. So that's your total surface area. Find the value of x. Let's write down the surface areas. So what do we have? We have a face right there. So the area of this is also going to be what we have at the back over there. So we have two of those. So we have two lots of this side multiplied by this side, which is x plus 2. So therefore we have 2x plus 3 times by x plus 2, and we have two of those faces, so we can write 2 there, plus next let's calculate this face right there, which is going to be those two multiplied, and of course we have another one over there. So therefore two lots of 2x minus 1 bracket x plus 2. And finally, we're going to work out this face right there, which is the same as what's on the bottom right there. So these two will be multiplied. So 2 lots of 2x plus 3 and 2x minus 1. Now all of this is of course equal to 172. So we can write that right there like that. Now all we have to do is go ahead and expand all of these. So first of all, I'm going to expand all of these brackets together. It's up to you. You can choose to expand those first and then multiply by 2. Totally up to you. But I'm going to choose to do the former. So in the first one we have 4x plus 6, and then I'm just going to repeat the second bracket. Next I'm going to have 4x minus 2, and then repeat this bracket. Finally I'm going to have 4x plus 6, repeat that bracket. That's equal to 172. Now I'm just going to expand these brackets together. So here I get 4x squared plus 8x plus 6x plus 12. Next one I get 4x squared plus 8x minus 2x minus 4. Finally on the last one I get 8x squared minus 4x plus 12x minus 6, that's equal to 172. Now I'm going to just collect all my like terms. So 4x plus 8x, that gives me a total of 16x squared. 8x plus 6x plus 8x minus 2x minus 4x plus 12x gives me a total of 28x. And finally, the numbers, if you add them together, and that gives us plus 2, which is still equal to 172 on the other side, which we're now going to move over to this side. So we have 16x squared plus 28x minus 170. That's equal to 0. If we divide this by 2, we now have 8x squared plus 14x minus 85 is equal to 0. Now, all you have to do is factorize this equation. Now, if you want to factorize this, there are many methods that you can use. You can use the AC method, which is to multiply these two numbers first, giving you a very large number. But there is a method that I've always taught, which is just to open up the two brackets and simply break up your x squared value. So usually the best way to break that up would be 4x. There is no best way really, actually. You'd actually just trial and error, but 4x here and 2x there. Hopefully when you're getting these in the actual exam, the numbers won't be so high like this. It will be a bit more user-friendly, let's say. But in this particular example, the first bracket is going to be 4x plus 17 and 2x minus 5. So therefore x is equal to minus 17 over 4 and x is equal to 5 over 2. Now, both of these cannot be our value for x, because let's take, for example, this one right there, x plus 2, this length right there. A length cannot be negative. And if we use this value to test this, so what is this? This is x is equal to, how many times does 4 go into 17? It goes in 4 times, so it's a minus, left over 1 over 4, so therefore x is equal to minus 4.25. Now, this value here was x plus 2, so therefore if the length is x plus 2, then we have minus 4.25 plus 2, which is equal to minus 2.25. And this cannot be a negative length. So therefore, this is our final answer, and that is where x is equal to 5 over 2 or 2.5. So question 17, here are the equations of 5 straight lines. Write down the letter of the line that is parallel to y is equal to x plus 6. So when two lines are parallel, they both have the same gradient. So what is the gradient of this right there? The gradient of that is 1. So we are looking for something that has a gradient of 1. So if you have a look through your list, you will see that this right there has a gradient of 1 as well. So the equation that we're looking for is y is equal to x plus 5, and the letter that we need to write here is r. Next, it says write down the letter of the line that is perpendicular to y is equal to 2x minus 1. Now, when two lines are perpendicular, the second one has the negative reciprocal of the first one's gradient. So if this one's gradient is 2, which we get from here, our second line must have the gradient minus 1 over 2. So looking at our list of straight line equations, we can see that this one has a gradient of minus 1 over 2. So the equation that we want is minus a half x plus 6 and the letter S. Question 16. ABC is an isosceles triangle. Angle ACB is equal to angle ABC. So if it's an isosceles triangle, then this length and this side here are the same. This angle and this angle are also the same. We are told that the area of the triangle is 60 centimeters squared. Calculate the perimeter. Now, of course, the perimeter is all of these lengths added up. So where do we start? Let's start by finding the height of our triangle, because we can use the area, which is base times height divided by 2, which is currently 60 centimeters squared. We know the base is 10, so we know that 10h divided by 2 is equal to 60. We multiply the 2 on the other side, so we get 10h is equal to 120, and therefore h would be equal to 120 divided by 10, which is 12 centimeters. So we now know that the height of our triangle is 12 centimeters. What we can now do is use Pythagoras' theorem to find the length x. So that is 12 centimeters. We want to find what x is. Now this is an isosceles triangle, so when we split this in half, we also have half of this length right there. So therefore this is 5 centimeters. How do we find what x is? We use a squared plus b squared is equal to c squared. Our c is our x, so therefore x squared is equal to 12 squared plus 5 squared, and that gives us, no calculator remember, so 144 plus 25, so x squared is equal to 169. The square root of 169 is 13, so x is 13 centimeters. What we can now do is say this is 13 and this is 13, so therefore the perimeter would be equal to 13 plus our 10, and that is a total of 36 centimeters. Question 15, write 0.16 recurring as a fraction in its simplest form. What we can start off by is say let x is equal to 0.16. It's a 6 that recurs, so ... And next what we want to do is make sure that everything on the right hand side of the decimal place is exactly the same, so we can just cancel them out. We can take that away. In order to do that, we need to manipulate our decimal values. So if we take this x and let's say multiply by 100, so we have 100x, then this 6 over here would take 2 steps and come over here, just repeating all of this on the other side. So we're going to have 16.666 ... all recurring like that. And then we take another version of this x and let's say multiply by 10. So we have 10x. So now go back to this. This 6 will end up right here, jumping once. So the 1 will end up coming over here. So we have 1.666 ... recurring. Next, we just need to take these away. So 100x, take away 10x is 90x, and 16, take away the 1 is just 15, and then all of this, take away all of that is simply 0. So we don't need to write anything there. So now we have 90x is equal to 15, and therefore x is equal to 15 over 90, which you can simplify by dividing by 5. So you get 5 over 30, and you can divide that by 5 again. So you get 1 over 6, because the question does say give your answer in its simplest form. So 1 over 6 is our final answer. Question 14, find the value of 64 over 125 to the power of minus 2 over 3. Now, when you have a minus in the power and you have a fraction, what you can do is flip it. So you can do straight away flip it by doing 125 over 64, and you have no more minus now, so you can just write 2 over 3. Next, I'm going to write this out separately just to make things a little bit easier to look at. So 125 to the power of 2 over 3 and 64 to the power of 2 over 3. Now this gives us cube root of 125 to the power of 2 over the cube root of 64 to the power of 2. The cube root of 125 is 5, so we have 5 to the power of 2. And cube root of 64 is 4, so 4 squared. 5 squared is 25, 4 squared is 16, and that is my final answer. All right, the next question. Now I'm going to have to zoom out on this question, so make sure you get anything that you need right now. Make notes on it. On the grid, plot a cumulative frequency graph for this information. Now I've already been given the cumulative frequency, so I don't need to be adding anything up like you normally might be doing if you were given just frequencies. So let's get straight into it. I'm just going to zoom out here. I'll try not to zoom out too much so you can still see what's going on. Right, so where are we plotting this 7? We are plotting on the upper bounds right there. So 17 will be plotted on the 160, 32 on the 170, so on and so forth. Students often make this mistake. I see this. They plot in the midpoint of these. So they plot the 7 in the middle right here. So they plot it at 145. They plot the 17 at 150. Mistake. Do not make this mistake, guys, all right? Right, we're going to plot the 7 on 150, so we'll find 150. Each of these small squares is equal to 1. I'm just going to zoom in here to show you this. So you can see from here to here we have 10, so therefore in the middle will be 5, and therefore each small box will be 1. So zoom back out again. So 7 will be plotted on 150 right there. 17 will be on 160 here. 32, 170 right there. 180 on 51 right there. 190 on 57 right there. And 200 on 60 right there. Finally, you can take a ruler now or draw it freehand. Just join these lines like that. Next, it says find an estimate for the interquartile range. So, interquartile range, the IQR, is equal to the upper quartile, which is our 75%, take away our lower quartile, which is 25%. Now, if you have a look at our graph, it goes up to 60. So, 60 divided by 4, which is our lower quartile, is 15. So, we just go across and read where it hits. So, roughly around, let's say, right there. And that is approximately 159. Let's just go with. Same for the upper quartile. So, it's going to be 60 divided by 4 times by 3. We know that 60 divided by 4 is 15, and then when we times that by 3, we get 45. So 45 right here. And it hits halfway in the middle. Let's just go with one of those values. Let's go with the second one right there. It doesn't matter which way. It all depends on how you've drawn your lines, and the examiner will give you some scope. So that's what, 177. So we have the upper quartile is 177, our lower quartile is 159. So if we take them away, we get 18. So our interquartile range is 18. Question 12. John plays a game where he can win, draw or lose. The probability John wins any game is 0.5. The probability that he draws any game is 0.3. He plays 2 games. Work out the probability that he wins exactly 1 game. Let's write down the probability of a win. The probability of a win is 0.5. It's given to us right there. The probability of a draw is 0.3, given to us right there. That means all that's left is the probability of a loss, and that's going to be these two added up, so 0.8, and that's left us with 0.2. Now the probability, if he plays 2 games, he wins exactly 1, it's going to be he wins the first one and he loses the second one. Or he loses the first one and he wins the second one. Or he could be drawing. So he could win the first one but draw the second one. That means he's won exactly 1 game. Or he could draw the first one and win the second one. And these are all our combinations that show exactly 1 win. So let's go ahead and find all these probabilities. So win and loss. In probability, and means times. So we are going to do 0.5 times by 0.2. And that's this right there. In probability, or means to add. So we are going to add the next one. So the next combination is where he loses the first game and he wins the second game. So the probability of a loss is 0.2 times by the probability of a win. Next, we're going to add again. So win is 0.5 times the draw, which is 0.3. Finally, a draw, which is 0.3 times by a win, which is 0.5. So these are all of our probabilities. Now 0.5 times 0.2 is 0.1. Plus 0.2 times 0.5, again 0.1, plus 0.5 times 0.3 is 0.15, and 0.3 times 0.5 is also 0.15. 0.1 plus 0.1 is 0.2, plus 0.3, 0 for the second one, and that is a total of 0.5. So the probability that he wins exactly 1 game is 0.5. Question 11. The points A, B, C and D lie in order on a straight line. A to B, B to D is in the ratio 2 to 5, and A to C, C to D is in the ratio 4 to 7. Find the ratio of A to B, B to C, C to D. Okay, where do we begin? Right, let's look at these ratios first of all. The first one has a total of 7 parts. So if you do 2 plus 5, we get 7 parts. The second one, 4 plus 7, is a total of 11 parts. Okay. Now, let's make a graphical representation of our A to B, B to D. So, if we have a straight line, let's just draw a straight line right there, and we label this A, we label this B, and we label this D, we are told that A to B is equal to 2 and B to D is equal to 5. If we do the same thing for the second line, so A to C and C to D, so A and D, and we have C, let's just say roughly around here. For the second one, we are told that it is A to C is 4 and C to D is 7. Now, both of these lines are still A to D, so we need to find a common ground between both of these lines. Now, if we go back to what we had up here, we can see that the first one was broken up into 7 parts, and the second one has been broken up into 11 parts. So a common multiple between them is going to be where you do 7 times 11, giving you 77 parts. So what I'm saying here is, let's draw a third line that breaks it up into 77 parts. So we have A here, we have the same B right there, so that's going to be B. We have the same C right there, so that's going to be C. And of course, we have our D right there. So there's D. Now, we said that we are going to break this into 77 parts, right? Because this one is broken up into 11 parts. This one is broken up into 7 parts. But this one is going to be where these values are going to be multiplied, so that we have a total of 77 parts. So in order to have the same common multiples, we will take the first one and multiply it by 11, and we'll take the second one and we'll multiply it by 7. So what do I mean by this? Well, if we take the first line, it's going to be multiplied by 11, and this one will be multiplied by 7. Therefore, this 2 will now become 22. This 5 will now become 5 times 11, so therefore 55. And if we go to the next line, this 4 will now be multiplied by 7, giving us 28. This 7 will be multiplied by 7, giving us 49. So that means from here to here is now worth 22 parts, so that's 22. And if this is worth 28 parts, that means just B to C is going to be 28 minus 22, which is 6. And finally, C to D can be just 49 because it's still representative of C to D, which is up here. So now we have this right there. So we know that A to B is 22. We know that B to C is 6. And we know that C to D is 49. And there is our final answer. Question 10. 10 students have a mean height of 150 centimeters. 4 of the students have a mean height of 165 centimeters. Work out the mean height of the other 6 students. Let's write down some of these. So take this one. So we know that something, let's call it x, divided by 10, because we have 10 students, gives us a mean height of 150. And if we have a look at the second one, we are told that 4 of the students have a mean height of 165. That means something, let's call it y, divided by 4 of these students is equal to a mean height of 165. Now, if we work these out, so therefore x would be equal to 10 times by 150, so 150 times 10, that gives us 1,500. And same thing for the y, we do 165 times by 4. You could use long multiplication for that if you're not sure how to do this. So let me just show you this quickly. So 5 times 4 is 20, 4 times 6 is 24, add the 2, 26, carry the 2, 4 times 1 is 4, and add the 2, which is 6, so 660. So therefore y is equal to 660 right there. So to work out the mean height of the 6 other students, we are going to do 1,500, which is all 10 students, take away the 4 students, which is 660, and that gives us 840. So now we know that 840 is the total height of the 6 other students. So to find their mean height, we're just going to do 840 divided by the 6 students, and we just need to simplify this. So 840 divided by 2, we get 420 over 3. So let's just use our long division for that. So 420 divided by 3. So 3 goes into 4 once, remainder 1. 3 goes into 12 now, 4 times, remainder 0, so we can just add this 0 here. So the total answer for the mean height of the other 6 students is 140 centimeters. Question 9. Liquid A has a density of 1.2 grams per centimeter cubed. 150 centimeter cubed of liquid A is mixed with some of liquid B to make liquid C. Liquid C has a mass of 220 grams and a density of 1.1 grams per centimeter cubed. Find the density of liquid B. So first of all, let's write down our formula that we need, which is density is equal to mass divided by volume, and different variations of that which we can derive from this formula. So we are told that liquid A, 150 centimeter cubed of it, plus liquid B, an unknown volume of it, is mixed together to give us liquid C, and again an unknown volume of that. So where do we begin this question? First of all, let's start off by finding the mass of liquid A. So we are told that liquid A has a density of 1.2 and the volume used is 150. So we can rearrange this formula in terms of M. So M would be equal to density times volume. So the density we are told is 1.2 times by the volume, which is 150 centimeters. So we just need to work this out. So what we can do is just treat this as 150 times by 12 for now, and we'll add the decimal place in later and multiply this. So 2 times 0 is 0, 2 times 5 is 10, carry the 1, 2 times 1 is 2, add the 1, which is 3. Next, 1 times 0 is 0, 1 times 5 is 5, 1 times 1 is 1, add them together, we get 0, 0, 8, 1. So we now need to put our decimal place in, so it's going to be right there. So therefore the mass is 180 grams for liquid A. Number 2, let's now find the volume of liquid C. So what do we know about liquid C? We are told that liquid C has a mass of 220 and a density of 1.1. So if we rearrange this in terms of V now, we have V is equal to mass divided by density. So the mass is 220 divided by 1.1. How do we deal with this? Well, if we multiply both the top and the bottom by 10, we have 2,200 divided by 11, and then we can just use long division again. So 11 into 2, nope, 11 into 22, it goes in twice, and no remainder, so we just inherit all those zeros. So therefore the answer to this is 200 centimeter cubed, which is the volume of C. And finally, we're going to find the volume and the mass of liquid B. So to find the volume, we know that the total volume used is 200, because that was the volume of what C was. 150 of that was A, so therefore 200 minus 150, which is 50 centimeter cubed, which is the volume of B. The mass, in a similar way, we know the mass of A was 180. We know that the mass of C is 220, so therefore it's going to be 220 grams minus 180 grams, which gives us a total of 40 grams. So now we know the volume and the mass of B. We now need to just find the density using our formula D is equal to mass divided by volume. So the density of B is going to be the mass, which is 40, divided by the volume, which is 50, and that gives us 4/5, which is 0.8 grams per centimeter cubed. And that's your answer for the density of B. Question 8, we have a hexagon, and we are told that CDE is 2 times the angle BCD, and we want to work out the angle of CDE. So CDE, which is CDE, this angle right there, we are told is 2 times this angle right there, which is BCD. So if we say this is x, this is going to be 2x. Now it's a hexagon, so the formula to find the sum of all the interior angles is n minus 2 times by 180. N is the number of sides, so seen as a hexagon, it's going to be 6 minus 2 times 180, which is 4 times 180, and that gives us 720. So the sum of the interior angles is 720. So if we add up all of these angles and take it away from 720, it will leave us with these angles. So if we add up 125 plus 129, 144 and 121, so 5 plus 9 is 14, plus 4 is 18, plus 1 is 19, 9 carry the 1, 2 plus 2 is 4, plus 4 is 8, plus 2 is 10, add the 1, which is 11, 1, 1, 1, 4, plus 1 is 5. So now we just need to do 720 minus 519. We can take that away here, so we have 10 minus 9, which is 1, 1 minus 1 is 0, and 7 minus 5 is 2. So 2x plus x, which is 3x, is equal to 201 degrees. So therefore x is going to be 201 divided by 3. And we just need to work out what 201 divided by 3 gives us. So 3 doesn't go into 2, but 3 goes into 20. It goes in 6 times, remainder 2, and 3 goes into 21 now 7 times. So x is equal to 67 degrees. Now the question says find the value of angle CDE. CDE is our 2x, so therefore 2x is going to be 2 times 67, and 2 times 67 is 134 degrees. Question 7, here is a cube. Work out the volume of this cube. Give your answer in standard form. So the volume of the cube is going to be all of those lengths multiplied by each other. So 0.05 times 0.05 times 0.05. Now 5 times 5 times 5 gives us a total of 125, and we have 2 decimal places here, 2 here, 2 here, so a total of 6. So we've got to give our answer a total of 6 decimal places. So 3 decimal places already by the 125, so 4, 5, 6. So now we just have to write this in standard form. So therefore the 1 needs to come over here, and that takes 1, 2, 3, 4 steps. So it's going to be 1.25 times 10 to the power of, remember it was a small number, so it's going to be a negative minus 4. So this is your final answer. Question 6. Dermot has 240 counters. The counters are either red or blue or yellow or green. 15% of the counters are red. 2/5 of the counters are blue. The ratio of yellow to green counters is 3:1. Work out the number of yellow counters that Dermot has. Right, so 15%, we want to find 15% of 240 counters, which is our red. And we want to find 2/5 of 240, which is our blue. So if we work this out, the rest of this would be yellow and green. All right, so let's go ahead and work out our red counters. So we have to use non-calculator techniques. So 10%, first of all, is going to be 24. 5% is going to be half of that, which is 12. So our 15% is going to be 12 plus 24, which is 36. So we have 36 red counters. As for the blue, then we're going to do 2/5 of 240. So it's going to be 240 divided by 5 and then times by 2. So let's work out 240 divided by 5. 5 goes into 24, it goes in 4 times, remainder 4. 5 goes into 40, 8 times, so 48. So 48 times by 2, that gives us 96. So we have 96 blue counters. Now we are going to add 36 and 96, our red and blue counters, and we are going to take this away from the total 240 counters, leaving us with just yellow and green counters. So 36 plus 96 is equal to 132, and we're now going to do 240 minus 132, which gives us 108. So 108 counters are either yellow or green. Now yellow and green is in the ratio 3:1, so that is 4 parts. So we're going to break up 108 into 4 parts. So 108 divided by 4. So 4, how many times does it go into 1? It doesn't. 4 into 10 is twice. Leftover of 2. 4 into 28 is 7. So 1 part is equal to 7. We are just interested in our yellow, which is equal to 3 parts. So therefore yellow is going to be 3 times 27, and 3 times 27 is 81. So we have 81 yellow counters. Question 5, we have an inequality where y is an integer. Write down all the possible values of y. Now you can see on your inequality that we have 2y. We just want y. So how do we do that? We are going to divide by 2. So 5 divided by 2 and 12 divided by 2, which is 6. 5 divided by 2 is 2.5, and we have y is greater than 2.5 or less than 6. Now an integer is a whole value. So the possible values of y, the first one would be 3. Second one would be 4, and the last one would be 5. So we can have 3, 4, or 5. Part B, solve. 4 is greater than 19 minus 3x. First thing, we're going to take this minus 3x onto this side to make it a positive, and we're going to take the 4 over to the other side. So we're going to have 3x is greater than 19 minus 4. 3x is greater than 15, and x is 15 over 3, and therefore x is greater than 5. Question 4, here is a graph of y equals 2x plus 6 minus x squared. Write down the turning point of this graph. And the turning point is going to be the point right here. So if you have a look at this, it is approximately 1 and halfway between 8 and 6, which is 7. So we can say 1 and 7. Then it says, use the graph to find the roots of the equation. The roots is where it cuts the x-axis. So where does it cut the x-axis? It cuts the x-axis at 2 parts right there. So if you zoom into these points, you just want to find what the value of x is. You need to know each of the squares, what they represent. So if from here to here is worth 2, then here to here is worth 1, which means each of these squares is equal to 0.2. 0.2, 0.4, 0.6, 0.8, 1. So what is this value right there? So this is 3, so therefore this is going to be 3.2, 3.4, and 3.6. So that's 3.6. On the other side, we have, this is minus 1, so this is going to be minus 1.2, minus 1.4, minus 1.6. So the two roots are minus 1.6 or 3.6. Question 3. In a bag, there are only red counters, blue counters, green counters, and yellow counters. A counter is taken at random from the bag. The table shows the probabilities that the counter will be green or will be yellow. The probability that the counter will be red is 2 times the probability that the counter will be blue. So that means if we say x is blue, the red will be 2 times that, so therefore 2x. Now there are 21 green counters in the bag, and the probability of a green is 0.35. So therefore 21 is equal to the probability of 0.35. Work out the number of red counters in the bag. Let's add up these two. So 0.35 and 0.2 is equal to 0.55, and take that away from 1, and that gives us 0.45. That means that these two probabilities are equal to 0.45. So we can say 2x plus x, which is 3x, is equal to 0.45. and therefore x would be 0.45 divided by 3, which is 0.15. So x is equal to 0.15. So if we go back here, we can just say that this is 0.15 and this is 0.3 because 2 times that. Now, going back to this, we want to work out how many red counters are in the bag. So currently we know that 21 counters is equal to 0.35, the probability. So if we go down to a probability value that we can use to work up to the probability of a red counter, so let's say 0.35, let's say if we can get it down to 0.05. So what do? We divide by 7. So we divide the other side by 7 as well. So 21 divided by 7 is equal to 3. Now, we want the probability of a red. So we want to get this probability up to 0.3. How does 0.05 go to 0.3? We multiply by 6. So the other side we also multiply by 6. So 3 times 6 is 18. So how many red counters are there? There are 18 red counters in the bag. Okay, question 2. Work out 3 over 4 minus 7 over 10. So let's go ahead and find our common denominators. So we know that both of them can be written over 20. So the first one, how do we get that to be 20? We times by 5. The second one, we times by 2. So the top 3 times by 5 is 15 and 7 times by 2 is 14. And we can just take the numerators away, which gives us 1 over 20. So our answer is 1 over 20. Question 2, work out 1 over 3 times by 3 over 5. So we'll convert the 1 over 3 into a top heavy. So 2 times by 3, which is 6, plus the 1, which is 7. So 7 over 3 times by 3 over 5. Now, we can multiply across or we can cancel down here. So we can get 1 out of that. So now we have 7 times 1, which is 7, and 1 times 5, which is 5. Now the question says, give your answer as a mixed number in its simplest form. So 5 goes into 7 once, and 2 over 5 is your leftover. Question number 1, to write 240 as a product of its prime factors. So 240, we will divide by prime numbers. So divide by 2, what do we get? 120. We can split that up further, divide that by 2, and we get 60. Divide that by 2, we get 30. Divide that by 2, we get 15. And divide this by 3, and 5 is also a prime number, so we reach the end. So we have 1, 2, 3, 4 times, so 2 to the power of 4. We have 3 times by 5. So that's your final answer. Hope you enjoyed this lesson. I will be releasing paper 2 and paper 3, so keep a lookout for that. Intro.
You know, you did intro.